Welcome to this webinar of our cycle, which is sponsored by the GRACE project, so our international Jean Monnet teacher training program, which focuses on active citizenship and the climate crisis. My name is Tiziana Faitini, and it is my pleasure to coordinate this project. And I'm glad to join you again today. After a while, actually, especially because today I have the pleasure to announce that subscriptions are open for our residency in Trento, which will be held at the end of March. And it will be actually a 4-day festival on citizenship education and climate change. Our program will include some workshops, conferences, and also art performances, inviting participants to rethink their relationship with the environment and also explore the role of education in fostering agency and European active citizenship. You can find the program link in the chat. I will put it in the chat in a second. And I want to highlight the fact that we can partially cover accommodation and travel for a limited number of people on a first-come, first-served basis. So be sure to check all the conditions on our website and apply as soon as possible. We are really waiting for you. Having said that, before we start, I just would like to remind you that, as always, there will be a question and answer session after the lecture, and you can either use the chat or raise your hand to speak. But please remember that our webinar is being recorded. Today's session is dedicated to historical reflections on the climate crisis, and more precisely to the political history of climate change and the response to it. We have the incredible opportunity to welcome Professor Jean-Baptiste Fressoz, who is a French historian specializing in science, technology, and the environment. Having previously lectured in London, he is now a CNRS research director at the École des Hautes Études in Paris, and his research focuses on environmental history and the history of energy and technological risk. And he blends archival and historical research with critical perspectives on how societies understand and respond to the technological change and the environmental changes. Among his publications, I will just mention 2 books that have also been translated into Italian. The first one is co-written with Christophe Bonneuil, so L'événement l'Anthropocène, La Terre, l'Histoire et nous, which is translated as La Terra, la Storia e Noi in 2019. And the second is Les Revoltes du Ciel, Une histoire du changement climatique, co-written with Fabien Lochet, a book which has also been translated as Le Rivolte del Cielo in 2022. More recently, Professor Fressoz published Sans Transition, Une nouvelle histoire de l'énergie, which offers a new history of energy and criticizes the very notion of energy transition. And this topic is precisely the focus on his talk today, which is entitled Energy Transition, a Reassuring Future Built on an Imaginary Past. And actually, you can see the picture already on the screen of that book that I was mentioning. So, Professor Fressoz, thank you so much for having accepted the invitation to join us today. And the floor is all yours.
Okay. Thank you, Tiziana. Thank you a lot for your interest and for the invitation to present my book. Basically, the book is really a historical reflection on a key notion, which is energy transition. And I think history has to play a role on this issue. What started my interest on this topic is when I started to read incredible declarations and strange affirmations by politicians on history, and the way history was instrumentalized, used, and deeply misrepresented to announce a future energy transition. very often when there are talks about energy transition, there is this idea that in the past, the world has been through different stages in its history of energy, different energy transitions, and what we have to do is like one step more, another energy transition, a new energy transition. We got several examples of this use of history. For example, Jeremy Rifkin, a famous promoter of hydrogen economy, uh, like an important expert, global expert, and guru on the hydrogen economy, explained that through history, humankind have been across different industrial revolutions. The first one based on coal. The second would be the shift from coal to oil. And now there is a coming shift from oil to hydrogen, right? So you've got a deeply wrong history of energy, which is used to announce a future age of, a future energy age. Um, if you take like John Kerry, who was the US envoy for climate change of the previous American administration, he explained that the energy transition is like a new industrial revolution, just like another industrial revolution, as if there was something analogous between the what has happened since the 19th century and what we have to do now, right? So there is a very strange understanding of what is industrialization in terms of history of energy under this sentence. Well, I'm not going to multiply the examples. I recently checked, actually, in Italy, you got exactly the same kind of idea that the energy transition is like a new revolution industriale. You also have this idea in Italian as well. You got that in Spanish, in German. You got like in every country, you find this ridiculous vision of history used to talk about the future of energy. Of course, the point is to create I mean, it's a political discourse, and the point is to create like a kind of enthusiasm from the part of investor to explain that, green technology, green energy, if that exists, is really the next big thing. So you have to invest your money in solar panel or wind turbine because this is the new industrial revolution, obviously. Um, Now, what is more surprising in a way is that if you look at the IPCC reports, so I guess you all know what the IPCC is. It's Intergovernmental Panel on Climate Change. There are several groups. I think it's worth spending just a few minutes to explain what the IPCC is precisely, because it will be important at the end of my talk. In the IPCC, you got several groups. The first group is about climate science, mainly staffed with physicists, climatologists, chemists. The second group is about impact, and the third group is about mitigation, basically what we have to do now to reduce CO2 emissions, right? The solutions in a way. If you take this group, in the last report, which was published 3 years ago, you see that what they have in mind is also a very strange history. Um, in one of the chapters, they explain that energy transitions can occur faster than in the past, which is really a strange sentence when you think about it. Or a low carbon energy transition needs to occur faster than previous energy transition. So they have this idea that in the past, there have been several energy transitions, and what we have to do now is just to go faster. And we have to globalize transitions that already took place in the past. As you know, probably the idea of energy transitions in history is very strange. These past energy transitions are quite mysterious in the sense that, as you know, we are burning more and more oil each year. We are burning more and more coal each year. There was some hope that 2014 was peak coal, and then it has expanded quite significantly. Now there is hope, which might be true this time, that we are living through a kind of peak coal in the next years, but I mean, it remains to be seen. And perhaps more surprisingly, we are also burning more and more wood. Wood energy is certainly not obsolete. On the contrary, wood energy has risen a lot in the 19th and 20th century. So we are living with all sources of energy. Like today, wood energy represents more energy than nuclear energy. Whereas, of course, we have the vision that the 20th century is the nuclear age, right? It is the great, this great, fantastic, enormous innovation. But no, no, no. Wood energy is more important for poor in the poor world, but also in the rich world. Actually, we are burning more wood, right? So really, we have a completely there's a really deep misunderstanding when you talk about energy transition in the past, right? I mean, to talk about that in the future, why not? But we have to remember that this is completely different from what we have experienced in the past. It is a radically new thing, right? Um, One of the very basic things that I think we need to keep in mind, sorry, the slide is in French, but I guess it's quite transparent for Italians. Um, it is that the history of energy and the history of materials in general is different from the history of technology. And I think it's a very basic point, but it needs to be underlined because when they when the colleagues talk about past past energy transitions, in fact, what they are talking about are technological transitions. What is changing is the technology, but the materials and the energies, they follow different rules, different dynamics. There is no substitution when we talk about materials and energies at the global level. And what I just said about energy, that everything is growing, go gas, coal, oil, and wood. It is also true for almost all raw materials. So it's not just a history, it's not just about energy, it's about all raw materials or almost all raw materials. There are very few exceptions to the rule that every raw material have grown in the 20th century. Very few exceptions. Um, One of them, and it's probably the only true counterexample to what I say, what I just said, is sheep wool. Sheep wool has decreased in the 1990s by one third because of the competition with synthetic fibers. But it is the only example of a kind of new technology rendering a material obsolete, right? I mean, to just summarize the thing in one word, raw materials are never obsolete. Technologies do become obsolete, but raw materials for the moment are not obsolete. And then, so you take the main raw materials, everything is growing, except sheep wool, as I just said, and also except asbestos and mercury. So there are two other counterexamples, but if asbestos, amiante, I don't know the word in Italian, but basically a very toxic material which was used to insulate homes, asbestos and mercury, um, it has decreased because there have been prohibitions, right? Like because it is toxic. So in many countries, asbestos has been prohibited. Even lead, piombo, lead. Um, it has, I mean, the use of lead in painting, in paint, and as an additive for gasoline, it has been prohibited, but nevertheless, lead has increased because there is such a growth of motor cars in Asia, and batteries are using lead that it has created a growing demand of lead. Even if lead is very well recycled, the extraction of lead has increased in the 20th century since the 1960s. So really, there is a key difference between history of energy, history of materials, and history of technology. And the problem is we confuse both. We talk about energy transition when we are just talking about technological transition, about change in the energy technologies. I mean, to just really underline this very basic point, I will give you two examples. The first one is the shift from the horse to the motor car, a very classic example of a major supposedly energy transition, very often invoked actually in contemporary debates around the energy transition. Actually, the number of horses in the world has remained globally stable since the 1960s because there are many horses in the poor world and there is a growing, I mean, population is growing in many countries in the poor world and they're using more and more horses for agriculture. And second, the main animal which was used in farm is not the horse, not the mule, it is the buffalo. And in the 20th century, after 1950, there is an explosion of the number of farmers in Asia. Fields are becoming smaller and smaller globally. Of course, we have in mind the European history or the American history, where fields are getting bigger and bigger, and we're using tractors, obviously, but this is not the general history. After 1960, there is a huge demographic growth in the world, and fields are getting smaller and smaller because there are more farmers, and they're using more buffaloes. So the number of buffaloes, which is much bigger than the number of horses, has doubled since the 1960s. We're at around 200 million horses. And third, and it is probably more important, of course, the horse is just an energy vector. It's not the primary energy. The primary energy, the biomass, which is fed to the horses, right? The oats which the horses eat. In the rich world, the US, Europe, the number of horses declined drastically after World War II, basically with tractors and motor cars. But actually, the biomass is increasing a lot, and it is used to feed other animals to produce meat, right? So the muscle is still there. And lastly, because of biofuels, we are using more and more biomass to power engines. Today, the biofuels use more corn, sugar to produce ethanol, soy to produce biodiesel. And all this biomass going into to biofuels is actually bigger than all the biomass which was fed to the horses in the 1920s at the peak horse, right? So I think it's quite important to see that if there is no energy transition, it is also because the producer of raw materials, they always find new outlets to their production. And we have the same problem with oil. Even if gasoline is going to decrease because of the electric car, oil will be used for other uses. The first one being aviation, shipping, plastic production. Plastic is increasing a lot. It's increasing very fast. It's one of the raw materials which is increasing very quickly right now. So you see, you got like a big spectacular technological change, the shift from the horse to the automobile or the tractors. But in fact, the story is much more complicated than that. The number of animals is growing a lot in the 20th century, and biomass is still used to power automobiles. Actually, automobiles today eat more biomass than all the horses and mules 1 century ago, right? The other example I would like to give you is the shift from kerosene lamps, oil lamps to electricity. Another major transformative technological transformation, which is electricity, which is, of course, a true technological revolution, right? And the electric light make the oil lamps obsolete in the interwar period with rural electrification. In the early 20th century, most of the people on the planet was using oil lamps, kerosene lamps. So a very basic technology based on petroleum and the oil lamp. Then came electrification, which of course made the oil lamp obsolete. But nevertheless, we are burning more and more oil to produce light. Today, the headlamps of the automobiles are burning more oil than the world economy in 1900 when everybody was using oil lamps, right? So once again, a major technological shift, enormous technological transformation, but the raw materials behind all this transformation, actually the history is much more monotonous. Everything is growing at different rates in different countries. It's different, but globally everything is growing, right? So really one basic point about history is that when we talk lightly about innovation as a solution to climate change or as a solution to an environmental problem, we just have to remember that the 20th century has been extraordinarily innovative in terms of technologies, new technology, and so on. Nevertheless, despite all the innovations, raw materials are never obsolete, and they are growing and growing and growing. Most of them are growing, right? So this is really a basic point, and it's important to have that in mind. And this confusion between history of technology and history of energy is why the colleagues from the IPCC write this well, mistakes, I mean, these stupidities, right? If the IPCC Group 3 talk about energy transition in the past, it is also because they have probably read a bit of history of energy. And it is true that historians of energy have fed this narrative of energy transitions. If you take the main books about history of energy, um, the key topic of the literature is energy transition. And it is quite easy to see that in the table of contents. When you look at the table of contents of most of these books, you got always the same structure. The first chapters will be about wood and water power in the 18th century. Then the central chapters will be about 19th century, Industrial Revolution, coal, the steam engine, the railways. And then in the 20th century, they will be mainly about oil, the automobile, electricity, right? So there is this very, very routine way of presenting the history of energy where you focus on the new at each epoch, the new technologies at each epoch. This is really a very common trait in history of technology, which has been beautifully underlined by a colleague of mine called David Edgerton in The Shock of the Old. And it is especially true for history of energy. Historians of energy have not really studied energy. They have studied the new technologies at each epoch. That's why there is so much literature on the steam engine and coal at the beginning of the 19th century. Actually, beginning of the 19th century, there were, like in the early 1800s, there were 2,000 steam engines in Britain. So we don't care about the steam engine before 1850, right? Most of the books by historians dealing about coal, they will be about the 19th century. Nevertheless, 95% of coal has been extracted after 1900. So the history of coal really starts in the 20th century, in fact. And most of coal has been extracted after 1950. And most of coal has been extracted not in Europe, but in Asia, right? So we really have uh, a problematic understanding of what has happened in the past because we are focusing on very cliche narrative about Britain, coal, the steam engine, 1830, whereas it doesn't matter, right? Um, Another reason for, I think, the big problem which is present in this historiography is that they look at history of energy in shares. The share of coal, the share of oil in the energy mix. It is what the historians are dealing with. And when you look at shares, you can produce this kind of very impressive graph. This is the share of coal in the total consumption of energy in different Western countries. And of course, it gives you the impression of a big transition from wood and water to coal. Coal is marginal in the early 19th century. It is central in most of the European countries, most Western European countries in the 1910s, right? Um, but the problem with this vision of things, it is that it tends to obliterate the fact that what is supposedly disappearing is actually increasing. What I mean is during the 19th century, we are using more and more water energy, hydraulic energy. Even before electrification, even before hydroelectricity, hydraulic energy has increased a lot during industrialization. In the same way, wind energy has increased a lot during the 19th century. There are more boats using sails, and there are also more wind turbines, windmills. There are millions of windmills set up in the US in particular, which are used for pumping water. So you got an enormous expansion of the so-called traditional energies during industrialization. I think I really like this example of windmills. This is a picture taken from the Chicago Fair in 1893, where you've got dozens of different models of windmills. It's because windmills were key for the Midwest, for the development of Midwest. In the late 19th century, you got millions of windmills which pumped water, which made possible irrigation, which made possible livestock raising. So it's really a key technology because, of course, the opening of the Midwest is really a big revolution in terms of history of agriculture. This is really a transformative thing. That's when really the price of wheat and corn starts to decrease, right? And then it is exported massively to Europe. Um, Nevertheless, this windmill in the Midwest is certainly not central to our understanding of the 19th century. What we have in mind is more like the steam engine and the textile industry. But food is more important than textile, obviously, right? Another energy which is growing a lot during the 19th and the 20th centuries is, of course, the human muscle. I just mentioned the fact that buffaloes, are growing in the 20th century, but actually there are more humans in the 19th and 20th centuries. They're better fed, and they are using much more efficient technologies, like not necessarily motorized technologies, very basic technology. Think about wheelbarrows, different kinds of carts, uh, but that that makes the use of the human muscle much more efficient. So the energy services produced by the human muscle are increasing a lot during the 19th and 20th centuries. Just think about the bike. The bicycle is a good example of that, of course. But the bicycle is just one small example of a massive shift and a massive transformation of all these tools which appears in the late 19th century, which use very basic technologies, but not so basic, like ball bearing, for instance. Ball bearing, something which allows you to reduce friction, is key for the very efficient use of the human muscle. And the problem in historiography, I said, first of all, they look at things in shares. They look at the new. They look this about energy in terms of shares, and they tend to obscure the fact that the traditional energies, the so-called traditional energies, are getting more and more modern, and they expand a lot. The last problem it is that historians have taken too seriously the names of the energies. What I mean by that, it is when they read about coal, they think that coal is just coal, or they think that oil is just oil, that the name is defining the thing. But it's more complicated than that. Uh, and I'll give you one example. This is a famous graph that you find in History of Energy in a very classic book by Anthony Wrigley, which is like the standard book on energy and the Industrial Revolution. Uh, you see the growth of coal, obviously. It's about Britain. It's quite interesting graph, actually. You can compare. I mean, we could discuss that later in the talk. I mean, you got Italy in the 1860s, 1870s, the small rectangle on the right, and the energy in Britain. So that creates there are a lot of interesting things to say on this graph. First of all, as you can see, there is an enormous rise of coal in Britain. And it seems that Italians in the 1860s are really, really energy poor compared to the Brits, right? There is a huge difference. At least, I don't know, like almost 6 times more energy in Britain than in Italy per capita. This is strange because there is no doubt that Italy is poorer than Britain in the 1860s. Nevertheless, like the common people in Italy or in Britain, their way of life is not that different, right? This graph creates many illusions. The first one is an enormous abundance of energy when coal enters the scene. Why? Because what my colleagues are measuring is primary energy. So this is the tons of coal, and they multiply the tons of coal consumed by the quantity of joules of energy that there is in a ton of coal. But as you know, and as I imagine you understand, this creates a big, big problem because, of course, the coal is used in very inefficient technologies. Like the steam engine in the 1850, which was very important in Britain, but not so much in Italy, they transform only a very few percentage of the theoretical energy that you got in coal into useful energy, like 3%, right? So when you see these graphs or these kind of graphs, you have to be very cautious. If you present that to your students, this graph is about primary energy, not about useful energy, not about energy services, right? So it creates an illusion that there is a massive transformation immediately when you start burning coal, but you are burning coal in very inefficient technologies like the steam engine. Gaslighting would be another example that really bias our understanding of what is happening in the 19th century, right? The other problem with this graph it is that, as I said earlier, they take for granted that coal is just coal and that wood is just wood, and that is wrong. If you see this graph, you see that according to my colleague, uh, firewood is disappearing in the energy mix of Britain mid 19th century. Like in 1850, there is no more like dark gray. I don't know if you can see the dark gray firewood. Yeah, dark gray. So you got light gray is coal, dark gray is firewood. So there will be no more wood in the energy system of Britain in the mid 19th century. And it's true that at the time, um, like most of British people would burn coal to heat their homes, and the steel industry had already shifted to coal, right? So it seems quite logical. But actually, it is deeply wrong. Why? Because to produce coal, you need an awful amount of wood. To the point that Britain in the 20th century is actually using more wood for pit props to support the coal mines than Britain was burning in the 18th century. Um, like the British coal mining industry used 4.5 million cubic meter of wood for pit props in the early 20th century, and Britain in the 18th century burned around 3.5 million cubic meters of firewood. So actually, Britain used more wood to produce energy in the 20th century than it did in the 18th century. And it is even worse than that because, of course, to produce pit props, you need construction timber. So you need a much bigger area to produce construction timber than to produce firewood, obviously, because you need to wait for the tree to grow, obviously. So in fact, Britain is using 6, 7 times more forests in the 20th century to produce energy than in the 18th century. So all the blah blah about industrial revolution as an energy transition from wood to coal, or as an escape from an organic economy, which is a really a key word that you find in historiography today, this is deeply wrong. This is not the proper way to understand the relationship between wood and coal, right? We have to think about wood and coal not as in competition, but as in symbiosis. They are working together. Without abundant wood, Britain or any industrialized countries would have had very little steel, no steam, no railways, no industrialization. So wood is not secondary for industrialization. It is key. It is absolutely indispensable, right? This is a picture from Cardiff Harbour in 1936. This is the pit props for the mines of Wales. So it's really a significant amount of timber, as you can see. The case of Britain is just one example. Like most countries, industrialized countries, consume more and more pit props to produce coal during the 20th century. A spectacular example is USSR, uh, which used enormous amount of Russian wood to support the galleries of Ukraine, the coal mines of Ukraine. So there is a massive transfer of wood from central Russia to Ukraine, and Ukrainian mines depended on the timber from central Russia. And at the collapse of USSR, uh, it was a disaster for Ukrainian mines because they still depended on wood to extract coal, and this wood was coming from Russia. So once again, when you think about coal, you immediately have to think about the wood that allowed the miners to extract the coal, right? Coal and wood are in symbiosis, not in competition. And you got exactly the same story about coal and oil. I mean, the idea that there is a shift from coal to oil in the 20th century is really strange. For one very obvious reason, um, petroleum was mainly used to power automobiles in the 20th century. And to make an automobile, you need a lot of coal. Um, this is a picture from the Ford factory on the Riviera Rouge in Michigan, near Dearborn. As you can see, there is a big stack of black thing, which is coal, because coal was the main ingredient going into a car, and it is still the main ingredient going into a car. In the 1930s, Ford needed 7 tons of coal to make a car because Ford company made its own steel and made its own electricity, right? Uh, so actually, at that time, like the 40 or the first automobiles, they didn't had such long mileage. Like after 100,000 kilometers, the car was dead. And at that time, a car consumed more coal than oil. So a car was more a coal technology than an oil technology at that time, right? Today, if you look at life cycle analysis, so I don't know if you know what life cycle analysis are. Basically, you look at all the materials going into the production of an object. If you look at life cycle analysis for the Chinese automobile industry, in China, which is by far the first car producer in the world, you need 2 to 3 tons of coal to make a car, be it electric or petroleum engine. Right? I mean, to make an electric car, you need a bit more coal actually for the battery. But really, a car is at when you see a car, you have to imagine that this is a big stack of coal. This is the first ingredient, even today. The second major ingredient is, of course, iron ore, because steel is still, we keep talking about lithium, cobalt, or whatever, but iron ore still remain the second most important ingredient for the automobile industry, obviously, right? Um, the other thing is once you got oil, of course, everything becomes much easier. You can transport raw materials in a much more efficient way. Um, what fascinates me is the kind of technologies which have not been studied by historians, which are not very central in our understanding of what are the important technologies, like the dump truck. The dump truck, camion à benne levante, I don't know the word in Italian, but the dump truck allows you to transport coal in a cheap way. Before the dump truck, coal was mainly used along canals, railroads, or in ports. But elsewhere, coal was very expensive because it was difficult to transport. Once you got dump trucks, suddenly coal is getting cheaper. So once again, oil and coal are not in competition. They work together, right? Because of oil, coal is becoming more and more cheaper. So we are using more and more coal, obviously. Or you are using coal in places where you couldn't use coal before. So oil increased the market for coal. It does not reduce the market for coal. Because what we have in mind is a kind of competition, that like the stoves, the heating system, they went from coal to oil, which is true. Like the boats, they went from the very complex and difficult to use steam engine to the diesel engine. That is true. Nevertheless, like the ships, they are made of steel, so they are using coal, even if they are diesel powered, right? So really, coal and oil, they work together. They're not in competition. And another important thing is that because of oil, wood energy is also becoming cheaper and cheaper. One of the big transformations in the history of energy from the late 1960s is the enormous rise of charcoal. So you use wood to produce charcoal, right? This is the first time in the history of humanity that you got cities in the poor world using charcoal as its main source of energy for cooking. In a city like Kinshasa, they burn each year 2.3 million tons of charcoal, which represents around 20 or 14, 15 million tons of wood, because there is a big loss between wood and charcoal, because carbonization is a very inefficient process. Paris in the 1860s, which was probably the city burning most charcoal in the world at the time, was burning only 100,000 tons of charcoal. So, like a city like Kinshasa actually burns more wood today than a country like France or Germany or Italy in the 1860s, right? So, really, wood energy has increased a lot in the poor world. Charcoal is really an interesting case because I mean, for most experts of the 1960s, wood energy was seen as kind of disappearing, becoming obsolete with economic development. But in the poor world, economic development and urbanization meant more and more charcoal because charcoal is an urban technology. It allows you to use wood energy in a city. And strangely enough, you also had this phenomenon taking place in Europe and in the US. I mean, the second part of the 20th century saw an enormous increase of wood energy in the rich world for several reasons. This has taken place mainly in the industry. All the all the wood industry, the transformation of wood in wood panels, for instance, is using wood residue. So it's a source of energy derived from wood. Another example, very interesting example I find is the paper industry, paper making, paper mills. Paper mills are enormous consumers of energy. It is the fourth industrial consumer of energy. Like the first is steel, the second is cement, the third is chemical industries, and the fourth is paper. And paper seems trivial and disappearing and so on, but in fact, no, it is actually increasing a lot because of packaging. So here you got a symbiosis at a large scale. During the 20th century, you got a growing economy producing more and more goods because of oil and thanks to coal. All these goods need to be packaged, obviously. So you produce more and more paper, cardboard to package the goods, and the paper industry is using more and more wood energy to produce to power its own machinery, right? So once again, more coal, more oil means more wood energy, right? Not a transition, and a growing symbiosis. Everything is expanding in symbiosis. Um, to summarize the first part of my talk, I give the example of Drax Power Plant. Drax Power Plant is a power plant in Britain, which was set up in 1972 to burn local coal. And around the year 2000, it was converted to biomass. And biomass actually means wood pellets. This wood is extracted from the US and Canada, and it is burned in massive quantities in Britain to produce electricity. Each year, Drax burns at least 4 or 5 times more than what Britain burned in wood in the 18th century. So after 2 centuries of energy transitions, we reached the great result that Britain is actually using much more wood to produce energy than it did before doing all these fantastic energy transitions. So it's really strange. So I mean, once you tell the history of energy like it should be told, like the expansion of everything and the history of symbiotic accumulation, how come that the idea of energy transition becomes so central? How come that it became so natural that we are all talking about energy transition all the time? The first thing so the second part of my talk will be about where does it come from, this strange idea, right? It's more like an intellectual and history of science thing. The first thing to notice it is that for a long time, experts about energy did not think in terms of energy transition. They rather saw um, the dynamics of energy as cumulative, and this is a good example of that. This is an exercise in forecasting proposed by a proponent of solar power in the US. What is interesting about this graph, it is that it shows very clearly that according to him, everything will grow. There, 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 there will be growth in solar energy, in nuclear energy, in coal, right? There is room for everyone. So for a long period of time, the future of energy was not seen as radically different from the present. It was rather seen an expanding present, as a bigger present, not as a different thing, not as something which has transited to something else, right? There is one group of scientists who start to think about history of energy and dynamics of energy in different way, and they are atomic scientists, US atomic scientists, who had worked in the Manhattan Project for the atomic bomb, and they were absolutely enthralled, fascinated by atomic reactor, by the breeder reactor, a specific kind of nuclear reactor, which allows you to have enormous quantities of energy using uranium. The word energy transition was invented by this physicist, chemist, physicist working in the Manhattan Project, Harrison Brown. Interestingly enough, energy transition at the beginning it's a term of nuclear physics. It designates a change of an electron around its nucleus. And this character recycled this word to talk about the future of energy. The idea of energy transition really emerged from nuclear futurology. It is quite clear in this graph. I will ask you to really look at the bottom graph, this graph. As you can see, It is they are imagining indeed an energy transition. All fossil fuels will disappear in the energy mix of the world, but look at the scale, the time scale on the horizontal axis. It is 10,000 years. So energy transition emerged from this neo-Malthusian thinking about the exhaustion of fossil fuels. There will be an energy transition in the end because we will have burned all the possible fossil fuel that there is in the world, or it will have become too expensive to extract, and nuclear energy will prevail. All fossil fuels, they have this, they make a peak, a kind of narrow peak, because it is contrasted to the unlimited plateau, energy plateau, which allows nuclear energy. So if you got the breeder reactor, you can reach like an endless plateau of energy consumption, like for thousands and thousands of years, right? So really at the beginning, energy transition emerged from this kind of forecasting, and it emerged in nuclear propaganda. And the problem, it is that we have recycled this vision to reflect on climate change and what we have to do facing climate change. Because the energy transition, when it was invented by atomic scientists, it was a very, very long-term futurology. I mean, according to Marion King Herbert, who made this graph, the end of fossil fuels is midway between now and 1,000 years. So you got four or five centuries to accomplish the energy transition. And this energy transition will be driven by the rising cost of fossil fuels because of scarcity, of growing scarcity. And nowadays, we have to do the energy transition not in 3 or 4 centuries, but in 3 or 4 decades. And we have to do it despite the fact that coal is very cheap and oil is still abundant, right? So it's a very different context. And nevertheless, we have recycled the same futurology, the same way of reasoning. If we all talk about energy transition today, it is in part because of this guy, US President Jimmy Carter. On the 18th of April 1977, he made a famous speech on television where he talked about energy transition. This is the first time that a politician talked about energy transition, and not any politician, but the US president. And what is quite striking, it is that when energy transition was introduced for the first time in the public sphere, it was based on a false history. Jimmy Carter was commenting on this graph, which is included in his US National Energy Plan of 1977. This is a very original way of representing energy dynamics. Because what is original is that you put everything in shares. This is the share of wood, the share of coal, the share of petroleum, right? So the trick is really to put everything in shares, and then you add wood and you see appearing like big shifts, big transitions. And Jimmy Carter said in the past, we have done two transitions, one from wood to coal, the second from coal to oil. And now, because of the oil shock, because of the energy crisis, we have to do a new energy transition. So it was really a way to, I mean, energy transition became really a common word because of the energy crisis. It is, at first, it was really just the atomic scientists who were talking about energy transition. But after 1973, energy transition became like the solution for the energy crisis. And as energy crisis was on every lips, everybody was talking about energy transition. When I say this is an original representation, it is because normally people would represent the energy dynamics like this. And of course, it's not the idea of energy transition that comes to your mind. It's more like energy addition if you look at this graph. So it's really an original graph. And this graph was stolen to a very, very important but forgotten Italian scientist, Cesare Malchetti. Cesare Malchetti was an atomic scientist, really obsessed with nuclear energy. And what he was advocating for was hydrogen. Basically, the way for nuclear energy to become really important was to mass produce hydrogen. So you would electrolyze water, create enormous quantity of hydrogen, which would be used in motor cars, airplanes, and so on and so forth. So he had this kind of crazy idea about the future, but he had also a very interesting hat, which was the hat of historian of energy. And he started to collect data at the global level to try to estimate how long this big transition from fossil fuels to nuclear slash hydrogen would take. And what he demonstrated was that in the past there was these big waves of energies. There was the wave of wood, the wave of coal, which would be followed by the wave of natural gas, the wave of the nuclear, like fission nuclear, and then what he calls solar solar and fusion. So it's really this vision of, the energy system is kind of driven by a slow evolution from one source of energy to another. This is really a new vision of energy that Cesare Marchetti started uh, to uh, to create, to build. Um, so as you can see, in the 1970s, the idea of energy transition started to become like an expert discourse, which was not the case before. Um, and this was really extremely convenient for many different people. The first group of people were the economists, were the first to study climate change. I mean, why we are all talking about climate change in terms of energy transition, it is because it is the same economists who had been energy economists during the 1970s, who had reflected on the energy crisis. It is them who started to study climate change and what we have to do. And they recycled this idea of energy transition, which emerged during the energy crisis, to reflect upon climate change. The best example of this transfer of reasoning and futurology is William Nordhaus. You might have heard of him. He got Nobel Prize in economics for his work on climate change. In 1973, he wrote a paper about the energy crisis. The argument is oil is getting more and more expensive. Many people in the USA, we should try to conserve oil, ration people, limit the consumption of oil because it is a scarce resource, which is extremely important, strategic for agriculture, for aviation, and so on. So we have to restrict demand. And William Nordhaus said, no, on the contrary, oil is expensive, so it is now that we have to extract it because it would be really a pity to limit our consumption because like we should not underestimate technological progress. And in 20 years, we'll have the breeder reactor. We'll have hydrogen. So that would make oil obsolete. So it is better to do the energy transition later. 2 years later, he wrote the very first paper by an economist on climate change, and he has exactly the same reasoning. There is an issue about greenhouse effect. There is an issue about climate. Does it mean that we have to tighten our seatbelt and reduce our consumption of oil and coal? No, because it will be much easier to do the energy transition later when we'll have the proper technologies. So really, the energy transition was a powerful instrument to justify procrastination, to justify delay, right? It's better to wait because we will be doing an energy transition later. Um, Then energy transition was very convenient for oil companies. I mean, the oil companies, late 1970s, early 1980s, were not climato-skeptics. They were not denying the fact that there is something called the greenhouse effect. This is really obvious. This is old science. Of course, we know that there is a greenhouse effect, but they were transitionists. They were already playing the transition card. And it is quite clear in the speech that the chief of Exxon R&D made in 1982 in front of climatologists. He said basically, of course, there is climate change, but it is true that there is also energy transition. And the important thing is that the energy transition will arrive before the climate catastrophe. And it was a very astute way to present the problem because the climatologists themselves presented the problem like this. I mean, we have to realize that the climatologists were very, very poor communicators, and they had I mean, the US climatologists were the first to talk about climate change in the public sphere. They kind of sabotage their own alarm, their own knowledge by saying that it will become catastrophic, but we have time. And the schedule was the following. Like in the late 1970s, you got paper explaining that climate change will be sensible around 2000. So people will feel that something has changed in the climate. It will have economic consequences by 2020, and it will be catastrophic by 2070. But when you write 2070, 1970, it's in science fiction. And the reasoning goes that, of course, we'll have done an energy transition in the meantime, because we all know that we have done energy transition in the past, that it takes 50 years to make an energy transition. Very, very weak reasoning on what does it mean to really get out of fossil fuels. And then energy transition was extremely convenient for governments. And then it's really the end of my talk. I come back to the IPCC Group 3. When the IPCC was set up in 1988, there was already a body of international expertise on climate change. It had been created in 1985 by UNEP, United Nations Environmental Programme, and the World Meteorological Organization. And like a dozen of climatologists explained that we know there is climate change. We don't need more science. We have to act. And what we have to do is cut the CO2 emissions by 25% before 2000. To do that, we need to put a carbon tax in the rich world to finance adaptation in the poor world, because climate change will happen whatever we do, right? We can delay climate change, we cannot stop it. So we have to adapt, and it is more difficult for the poor world to adapt. So this climate tax, carbon tax, will be used for financing adaptation project in the poor world. In 1988, there is a climate conference in Toronto, in Canada, where you got already like 40 governments represented in this conference, and the final declaration take this advice. So the final declaration explained that we have to cut by 25% CO2 emission before 2005. So it's 5 years later than the report of the experts, and we have to set up a carbon tax. When the US government heard about that, they fell off their chair. For the US government, at that time, George Bush, it was seen absolutely unacceptable that a bunch of climatologists and UN bureaucrats would start, defining what we have to do. At that time, the US were by far the biggest emitters of CO2. So what they said is we need to create a new body of experts to really, this bunch of climatologists at the advisory group on greenhouse gases are not serious. What we need to do is to create an intergovernmental panel. So the important letter in the IPCC acronym is the I. It's I for intergovernmental, not international. Intergovernmental, it means that, and it's quite clear in the US diplomatic archives, it means that we will ask to governments to nominate experts. But we want people from a variety of the policies of each government, which means that we want people nominated by the Ministry of Industry, by the Ministry of Agriculture, and also by energy firms. So we want serious people, people that internalize the economic constraints of really fighting climate change. When the IPCC was set up in 1988, there were three groups. The head of Group 3 was Robert Weinstein, the guy with the hat. Interestingly enough, he was also openly climato-skeptics. He was a climate denier. It seems strange that the head of an IPCC group is negating climate change, but actually the head of Group 2 was also climato-skeptic. He was a Russian called Yuri Israel, one of the rare meteorologists who was climato-skeptic at the time, and he was heading Group 2. So really at the beginning, the IPCC is a delaying tactic. There is a rising concern among scientists and climatologists about climate change. Let's create, something intergovernmental, extremely complicated, very heavy to produce knowledge and expertise from time to time, right? It's a delaying tactics. Robert Weinstein was also, so he was chief of Group 3 of the IPCC, and he was also chief negotiator for the Rio conference of 1992. The Rio conference is really a big conference. It's really important because it is when all the international system of governance around climate change is set up, right? And we know about the US strategy at the Rio conference because Robert Weinstein gave a very interesting course to students, actually in the US, future diplomats, explaining how you manage international negotiation like this, how you manage the negotiation so that it fits US interest, US government's interest. And he explained that he took his order from John Sununu, which was George Bush chief of staff in the 1990s, early 1990s. And John Sununu was very clear. At Rio, uh, do not commit the US government to any target about emissions. So no target. Do not promise money because all this debate around climate change, it's just an excuse for the poor world to ask money from the rich world. So out of the question, no target, no money, play the technology card. Talk about energy transition. Talk about innovation to solve the climate issue. And of course, it makes perfect sense. I mean, the US at that time were the biggest emitters. They were also the main technological power. So it made sense to explain that we will go out of this mess through technological innovations, right? And play the technology card. This is precisely what the IPCC has been doing for the last 30 years. If you look at the report of the IPCC Group 3 from 1992 until the last one, most of the discussion is about new technologies, about innovation. For a long time, it was nuclear technology, which was thought as very important. Now it's more and more renewables. But I mean, all the questions of sufficiency, of limiting demand, basically, they remain marginal. It is only in the last report that you start to have like a significant treatment about sufficiency. Degrowth is still absent. I mean, it's basically they have been in charge of reflecting about solutions to slow down global warming or even stop it, and they have not started to imagine reducing the size of any economy in the world, even the richest, right? If you take the last report, it is extraordinarily technophile. In the last report, the Hyperloop of Elon Musk, I don't know if you know what the Hyperloop is. Hyperloop is a kind of science fiction train. It's a magnetic train which will go through tubes where void will be made, so there is no friction, so it can go at like 1,000 kilometers per hour. Well, it's a crazy thing, like many things Elon Musk says, and it is described as an emerging technology, right? So in the 2007 report, they were talking about nuclear fusion as being the technology of the future before 2050, right? So there will be nuclear fusion reactor commercially available by before 2050. So it is very technophile, uh, and it has not worked at all, or almost not at all, on sufficiency, degrowth, limitation of demand, and redistribution, which will be the key of the public discussion around climate change. Uh, if you take the forecasts, not the net zero scenarios, but the forecasts, given the price of different sources of energies, given the diffusion of renewables, of electric cars, given all that, what the International Energy Agency envision is something like this. So as you can see, coal will diminish, mainly thanks to solar panels in Asia before 2050, but oil and natural gas remain quite similar to now. There is no transition coming. What we are experiencing is more like a plateau than a rapid phase out. And it is quite normal because energy transition is radically strange. It is a very, very strange futurology. And what I found interesting is that history of energy has played a key role in making this idea of energy transition seem plausible. You know, history of energy, a wrong history of energy, has played a key ideological role in making us believe that we could get out of this mess through technological innovation. Because in the past, we have shifted from energy to another, and we will shift to a new source of energy which will not cause CO2 problems. But this is deeply wrong. So energy transition, to summarize, and it will be my last sentence, I promise, energy transition projects uh, a path that does not exist, sorry, a path that is not true on a future that remains quite elusive or mysterious. Okay, thanks a lot. I hope it was clear, and we've got like 30 minutes for discussion, perhaps.
Yes, of course. Thank you so much, Professor Fressoz. I mean, it was a very rich and vivid presentation, albeit somewhat discouraging, maybe. You have made very clear the global dimension of history and of our connection to faraway places. So also about the partiality of our historical accounts, giving us some additional reasons to advocate post-colonial reasoning, so to say. I found the example of buffaloes and horses very compelling in this regard. And perhaps even more compelling is the fact that most of the coal was extracted after 1950 and not in Europe, and not even in one of the leading countries of the Industrial Revolution and its textile industry,
Mm.
as it should be according to our old history of the spinning jenning and the mechanization of textile production. So a counterintuitive history,
Um,
which sounds very important in this sense. And secondly, you have made it very clear that we should talk about energy addition instead of energy transition, and that the use of the very term energy transition somehow distorts the way we think about the transformations which are needed to tackle climate change. So this idea that energy transition is a historically implausible solution is quite, you know, discouraging in a way, but also powerful. And I just would like to highlight a methodological point, which makes your contribution very meaningful to me. And this is the fact that you have demonstrated not only the importance of considering the economic and technological and material factors underlying climate change, but also, and more specifically, the importance of analyzing the discourse on these factors and the justification of these factors and the public, academic, and political accounts for these factors. And this points out to the strategic importance of critical language analysis and also of a critical history of sciences and discourses. And this goes back to the fact that the language mediates our perception of reality and justifies policies, collective choices, but also collective aspirations. So our very dreams. And so, and your talk has powerfully shown that there are no neutral concepts, not even in hard science, not even in physics, not even for sure in history and politics. And so I'm very grateful for your work and for your talk this evening. And I'm pretty sure that there are some questions and curiosities, and I will invite you all to join the conversation. You can either use the chat or raise your virtual hands to ask your question. I will just wait a moment to see if somebody has a question. And
or it could be a comment, a critique. I mean,
yeah, exactly. But maybe I'm just going to ask you a big question in the meantime. So, in the waiting for other people to join. So, the picture you have drawn is quite discouraging in a way, as I said, given that the energy transition lies at the heart of many social actions, the IPCC panels, and also of most of the EU policies aimed at tackling climate change or the climate crisis, we should perhaps call it. So, what is your concept and your, not a solution, but perhaps your the way you would indicate for what we have to do? I suppose your concept is the growth, as you said at the end. So this idea of limiting the demands and sufficiency, but maybe you want to add something about that.
I think my starting point was not to be normative. And the big problem about many social sciences around climate change is they started with a normative perspective, what we should do. And that kind of distorted their understanding of the problem. And I think it was quite presumptuous to think that, social sciences could find a solution to this thing. When you think about it, it's a bit ridiculous to imagine. I mean, I got colleagues from philosophy saying that, I got this grand theory which helps you solve this big problem. I find it's quite quite weird. I mean, and certainly
Right.
not modest enough. Um, I think about words. I really like the way you framed it at the beginning when you said, it really shape even our dreams and our
Mm.
aspirations. I think it's really a good way to frame the problem. If you don't want to talk about dreams and aspiration, what we do with all the new technologies that we are presented with, like solar panels, windmills, electric vehicles, we don't do an energy transition. We decrease the carbon intensity of the economy. We decrease the amount of carbon that we emit to produce a certain service, a certain amount of kilowatt hour. And I think it's very important to present the thing like this. Why? First, because it forces you to leave on the table the size of the economy. It is one parameter that should be part of the discussion. If you say energy transition, you make believe that we will have solved this issue in 30 years' times. And once we will have solved this issue, everything can go on like before. We can grow the economy forever uh, without interfering with the climate because we will have completely disconnected our economy uh, from carbon. This is really, I think, a very, very misguided understanding of the future. Um, it is most probable, like what the International Energy Agency showed, that there will be CO2, there will be carbon in the economy after 2050, and quite a lot of carbon. So I think the big question that energy transition prevented us to ask is what we do. What is this carbon for? Is it to do something useful? Is it to do something luxurious? I mean, it should be one of the key topic. So it is about redistribution between uses, between people, between countries, between social classes. I mean, energy transition really allows you to really put on the side all these very big political questions that we don't want to discuss. So I think it has a very, very dangerous political, it has had a very important and dangerous political effect. So about really the words, it's about carbon intensity, size of the economy. And I think these are quite neutral words. Of course, they're not very, it's not an aspirational thing. To decrease the carbon intensity of the economy doesn't, it's not about dreams, it's about technologies, it's about what you can really do. And the other important thing when you say decreasing the carbon intensity of the economy, it is because we have done that before. We have been here before. We have decreased a lot the carbon intensity of the economy in the past. I'll just give you one example. Um, in the 1910, 1920s, industrialists got rid of the old steam engine and they replaced them with electric motors. As you know, electric motors are extremely efficient. When they did that, they divided by 10 the carbon intensity of industrial force. Today, when you replace a gas power plant with solar panels, you divide by 10 the carbon intensity of electricity. So when you understand things not in like energy transition or all this slogan and rubbish, but as something which is part of uh, a tendency of technological progress, basically, you see that it's not that revolutionary. Electrification is an old story. It has already helped us a lot to decrease the carbon intensity of the economy. It's just a new step on this diminishing carbon intensity, right? And most of the technology we are talking about, like electric vehicles, we say it is transition, but no, it's just technological progress. If there had not been the climate crisis, there would have been electric vehicles sooner or later. And we have talked about that as a technological progress. They are silent, they pollute much less, and they emit less CO2 even on a life cycle analysis, right? So it's about language, technological progress, energy efficiency. It's not fashionable enough, and of course, it does not solve the climate change. So we don't talk about all these technologies like this, but we should be talking about these technologies like this. And that allows me to talk about the symbiotic relationship between renewable technologies and fossil resources.
Thank you.
Um, as I said, like solar panels, they divide by 10 the carbon intensity of electricity. So there is a symbiosis. I mean, in the sense that to make a windmill, of course, you need steel, so you need coal. To make a solar panel, you need silicium and steel and aluminum and silver and many other things that are still dependent on fossil fuels, but it's not that much. It's not really where the big amount of fossil fuels are used. The big amount of fossil fuel will be used in the future to produce automobiles. So the key thing is what do we do with all these clean or rather clean and electricity? If it is to power 1.5 billion cars and growing perhaps, then you need a lot of steel. You need a lot of other materials which will be dependent on fossil fuels. And if you've got a growing number of cars, you've got like growing cities, more buildings, more houses, bigger houses that you fill with stuff and objects and consumer durables. I mean, you reduce the carbon intensity of the economy, but you certainly do not reach net zero with electric vehicles. And it's the biggest problem is also not just the symbiosis between between fossil fuels and all these green technologies. It is that in many sectors there is no transition at all. The only place where there is really a transition is electricity production. I mean, you can use the word transition, I think, for electricity. And in fact, many countries have already transited out of fossil fuels for electricity production. France is one example, but Norway, Sweden, with hydraulic energy in particular, got many countries which are not emitting or almost emitting no CO2 for electricity production. Obviously, these countries, and France in particular, are emitting far too much emissions, far too much CO2. So all the rest, it's not really about transition. A car, it's like when you use a car in a country like France or Norway, you divide by 3 or 4 the carbon intensity of the kilometer. Because a car, it is made of coal. And even if it's an electric car, it is still it's not growing on trees, right? Obviously. So and it's of course electric cars are not zero CO2. Of course, it's like a half solution, so it's still a problem, right? So yeah. Then when I'm talking about the other sectors, you got steel, which will be very difficult to decarbonize, cement, almost impossible to decarbonize, plastics, which are dependent on coal or oil or gas. You got agriculture. We don't talk enough about agriculture. The, the food system, from deforestation to the management of waste, represent 1/3 of greenhouse gases emissions. Here we are not talking about major technological change. Reduce demand, you can reduce meat consumption, obviously, but we are not talking many sectors where this idea of energy transition is just a ghost, just doesn't exist, right? And that's why the curve I show you from the International Energy Agency, they don't, I mean, we still need a lot of fossil fuels for all sorts of things. Um, yeah, sorry, it's a long answer to your question. But really about the words, I don't think there is like the right word. But
No.
I mean, if you just remain scientific and rigorous, it's about diminishing the carbon intensity of the economy. And once again, since the 1980s, the carbon intensity of the global economy has been divided by 2. So we have been through huge progress in the past. I mean, it's not a, it's about technophobia. I mean, I'm an historian of technology. I know technologies are getting more and more efficient, but in many parts, the gains of efficiency are behind us. They are not just in front of us.
Thank you so much. That added a lot for us to think about. And we have another one question in the chat, another question in addition to the one you have just replied to. And it is by Raul Pinto, who is joining us from Portugal. And he says like that: I think that the ideas presented will not become mainstream because predominant political discourse. And he wonders about the reception of these ideas in the academia instead. So how are these analyses met in the academia?
Or in academia, it's probably not the most. I mean, some people wrote very nice reviews saying this idea of energy symbiosis is really fresh and interesting, and they were interested in the conceptual history of energy transition. You've got critiques from. I was surprised from. Well, it's not really important, but from one Marxist thinker, historian or thinker in the US saying this is depressing. and degrowth, you can't sell it, so don't talk about it. So there is no politics. So this kind of, but it's more like an a priori critique. It's not about the empirical content, so I don't really care. Um, and I think more interestingly enough, there is no reception at all by politicians because it's not very pleasant to hear. But there is a very important reception from civil servants, engineers, experts. Like I made a talk recently to the DG Energy in Brussels. Next in 2 weeks' time, I will talk at the European Central Bank. So people that are not dependent on votes, like technocrats, they want to understand what is happening, right? They don't care if it is depressing or not. They want to know what will. I mean, it's about also trying to understand what is happening to us, right? So here I had very interesting discussions, but to be frank, these people are well educated, they have thought about that, and most of what I say, even if they don't know the detail, they kind of already knew that. I mean, they know that this idea of energy transition is just rubbish. They know that. They know that you won't have hydrogen still globally on a massive scale in 30 year time. This is ridiculous. And they haven't talked about negative emissions, which is like one of the biggest scientific scandals of the recent times. Because what I said, many sectors cannot be decarbonized. The IPCC has come out with this idea of negative emissions. What we can't decarbonize, we'll compensate it through innovation, one again, but innovation that will allow us to pump CO2 from the atmosphere and put it in the ground. The machines do not exist, it's not possible, but it doesn't matter, right? We just keep that in the model to pretend that we will reach carbon neutrality, to pretend that the 2-degree target is still achievable, whereas everyone knows that this is ridiculous, that we'll be way over 2 degrees. So yeah, I mean that's it's kind of I don't know, like I mean, very often there's a tendency to think that science is really saying the truth, and then there are the nasty lobbies who tries to influence the understanding of things. But in many ways, the science of mitigation has been co-constructed with lobbies. Like, why does the IPCC Group 3 talk about negative emissions? It's because they took this idea from the fossil fuel industries. Since the 1990s, these people have pushed this idea of carbon capture and storage because, of course, it's the way to go on like before. And then this idea became palatable for the IPCC because it was a way to make believe that we could still reach the 2 degree target. So there is an interesting interplay of lobbying from fossil fuels and also good meaning experts who want to motivate the government saying, yeah, yes, you can do it. We can sign the Paris Agreement because we've got all these fantastic, these possibilities of capturing CO2, whereas we don't know how to capture CO2. It is extraordinarily expensive, very electricity consuming, many problems that it creates many problems anyway. So yeah, I don't know why I was saying about saying all that, sorry, but I think we have to be critical about the all the about this very technophile orientation that the mitigation expertise has taken. It's really leading us nowhere.
Yeah, and it's also really a very good example of an ideological justification for a very specific economic development. So in a way, it's again, it's a bit depressing, as your American friend said
Mm,
about the actually the political appeal of this kind of analysis in a way. But at the same time, probably it would be very important to be able to translate this kind of analysis into a public discourse,
mm,
into public analysis. And the work you are doing in this regard is great. I mean,
thank you.
your book has been very
Mm,
widely discussed, and also he has some very important reviews also, at least in some newspapers and magazines, if not in the full academic and political debate.
mm.
I wonder whether there are some final questions for our guest. I don't see anything. And yeah,
I
maybe.
mean, I think one of the key thing, I mean, since I'm talking with teachers, just to teach a proper history of technology, of energy, that will help to have more critical thinking on that. I mean, and I think history, I don't know if you have history teachers in the room or other disciplines, but it's really something we should teach to the students. And you see that the narrative that we rehearse in schools and but also in universities, it's not just about high school, it's also universities actually. I mean, we're not better. Uh, it has strong ideological consequences. And so I hope that, I mean, there is a new kind of history of energy that will be taught in the future to really be able to think properly on this enormous thing like climate change.
Yeah, and this would also mean that we need new historical books and handbooks in order to radiate and spread this kind of new narrative, which, as you said, has a very strong ideological basis otherwise. And I find it very important to highlight also the colonial bias in our narrative, usual narrative of history. So the very fact that we only focus on the history of Europe and within Europe itself, on the history of England and of some very parts of our continent. So we really need to have a full discussion among teachers and also to develop new tools and handbooks in this regard. Thank you also for highlighting the question of redistribution. This was also very important in my view. So the idea that we need to shift the focus from energy transition to the very question of the use of carbon, oil, and whatsoever. So we need really to discuss and analyze publicly what we are using these raw materials and these energy for. And so our discussion should really go back to the idea of the use of this means, which should be means at least. So thank you so much. I think we are just heading towards the end of our conversation. And I just want to thank you very much for your powerful talk and also for this wonderful discussion. As always, we would like to get the feedback from our teachers and from our participants. And to that end, there is a link to a quick Mentimeter poll in the chat. But I'm sure that all of us were really amazed by this presentation. Our next methodological webinar is scheduled on 19 February, when Manuela Callicalzini will hold a workshop on teaching sustainability through storytelling. And I think that this evening we had a real idea why storytelling is so important and can be also so important in everyday classrooms. You have all the info in the chat together again with the link to the program of our forthcoming festival, which is programmed in Trento from March 26th to March 29th. I just want to thank again Professor Jean-Baptiste Fressoz for his wonderful lecture, and thank you all for having been with us this evening. Thank you and bye.
Goodbye.
Goodbye. Thank you so much, Professor.